Pay attention to load paths. You'd be surprised at the number of cars that we see that just don't have any consideration for load paths.
That old bugger Newton also had another thing about for every action there's an equal and opposite reaction. So when you put an action in, if you don't have somewhere to go and to react, something's going to bend, something's going to break, something's going to flex, something's going to go out of alignment. The inside rear wheel is going to fall over on the positive camber and destroy your tires and all the other things. You have to feed those loads. Well, you have to react them.
I'm only a humble engine man. I look at some suspension and think I wouldn't clean a pipe with those. I just asked the question, has anybody bolted a big bar to their wheel and just leant on it to see the camber change from just putting a little bit of load into the tyre, like a cornering load? Because you can do it statically in your garage and just see what camber change you're getting. You go and see photos of some of these cars running and the wheels have gone to strange angles, positive camber, which you think, I'm sure they didn't intend that, but the pipe cleaners they've hung it on definitely allowed it.
I can tell you an exact example of that. In 2003, the university from Australia, that was a university 50 or 60 kilometres south of Sydney, University of Wollongong, and they built a lovely little tube frame car which won the Australian competition, and then they took to the US, and they were the first foreign team to win in the US, which was quite a bit of a fuss at the time.
It was.
They called the car Stumpy because it looked like Stumpy the Wombat. A wombat's a little stumpy animal that's in Australia. A very, very effective car. Now, after they ran the Australian competition, I showed them some pictures that I'd taken from the rear of the car, which clearly showed a very significant amount of positive camber on the loaded outside rear wheel. I sat down with the engineers who had done this to talk about it, and they said, absolutely no way, it cannot happen. And it couldn't happen in the suspension kinematics. Jeff just told you what happened. The tire, the wheel had flexed. And of course, what happens if you apply that helical flex load to a wheel by rotating it with a lateral load? What's going to happen? Come on, what's going to happen?
Those positive camber.
Yeah, but what happens after it's been on positive camber for a while? All those molecules say, I want to get divorced, I don't want to be here. Crunch and the wheel breaks. Ever seen a wheel center break out of a wheel? We sure have. So the team went away and they designed in CAD and FEA a new wheel center with proper load paths that fed the load from the center line of from the wheel, from the rim down into the hammer. And all of a sudden, not only was the car easier on its tires, but on their test track was maybe a full second faster. And a huge leap forward, so they took that car to the US competition, at the time, well, still I guess, the most difficult competition to win, and they literally ran away with it. They ran away with it. Now, we've had a helper, Michael here, team leader from last year's winning team, and I guess we've been playing with him a bit, playing with his head. He's our apprentice. He's our apprentice design judge for next year or the year after. And one of the questions we asked was about running wire spoke wheels. What we were really talking about was it's easy to imagine the load path if you imagine it passing through a wire spoke. You can imagine where it goes. And what makes a wire spoke wheel strong and does or doesn't. And it took a little while for Michael to realize what the hell we were talking about. But eventually the penny dropped and clicked, didn't it? Who's checked for flexiness with a piece of water pipe, really easy to do? Anybody ever checked the flexibility of their wheels? Anybody just bought cheap wheels from a supplier? A couple of American brands we won't mention. I'm sorry, not because
Australian brands? Or American
no,
brands?
I don't think anybody makes that sort of wheel.
You sure?
I don't think so. No. But there are a couple of American speedway type wheels which
Yeah, there are.
Yeah, which aren't very good.
Yeah.
They're still in wood in Australia, that's why.
Yeah. We've got this really clever thing. You make a big ring of steel, you weld it together, and you weld it together by putting it in a forge and hammering it with a hammer. Then you heat it all up and you drop it over the wood and it squeezes in and holds these wooden wheels together. Works really well. Incidentally, do you want to ask Steve Fox about heating steel rings up and dropping them onto things and how much fun that is?
Safety first. You all should be very careful with what you're doing with your car. You only have one pair of eyes. Use them to your best advantage. You can't afford to lose one.
We've seen people grinding and welding and God knows what without eye protection here over the last few days. Let me tell you, your eyelids are not UV proof.
No?
You know, cataracts and all that stuff will come from that. You're only young. When you get to my age and maybe you have to wear glasses, you'll think, shit, I should have listened to Pat when I was a bit younger. But as Steve says, you've only got one pair of eyes, that's all you got. You'll lose one. Like, how many people here would like to have some sort of a career as a race driver? Well,
No one?
nobody like to, even for fun.
We're talking to the wrong crowd, Pat.
Yeah, I guess. Yeah. But there's an FIA rule about monocular vision. You don't have two eyes, guess what you can't get? Your racing license. You may be able to see. So I guess maybe you could be an engineer with one eye. You certainly won't be a driver of any note. They're certainly not in any international level of formula.
Even in engineering, on many drawings at Cosworth where handwork was involved or surface finishes were required, there was a note on the drawing that said, inspect by eye, use a good one.
Yeah, not the glass one. And that's what you'll end up with, grinding and one day when you've got nothing better to do with your time, calculate the velocity at the outside edge of the disc on an angle grinder and think what happens if a little bit of carbide comes off there or a chip of steel and just goes straight into your eye. All over.
Any other questions? Anything you guys would like to talk about?
Go ahead.
I'm a mechanical engineer.
Oh shit.
Pat, you're a mechanical engineer. Jeff?
Electronics are obviously very important on any modern motor vehicle. Now, you can take two ways to do this. You can either buy off-the-shelf electronics and you're simply playing with the buttons and knobs and dialing in values. Or you can go away and build your own CAN bus system. Something like that, very worthwhile step. It teaches you a lot about electronics. We're luckily going slowly enough that the processor can keep up. There's one car here with a CAN bus system on, and when I checked out at maximum speed, it can do 110 miles an hour before all the lights will go out. That's based on the frequency of the triggers on the wheels and things. It would run out of speed after that, but for what you're doing, there's things you can do like that, and that gets you to only 4 wires in a wiring loom, so much more efficient looking electrics on it. Then there's all the other electronics, the traction control, aids like that. They're all things that you can explore, but they're just things that as a team you can decide to do or not to do. You know, is it something you want to focus on and perform at?
How many of you have color-coded wiring harnesses? Different colored wires in your car? Okay, some. On the rest of you, all the wires are black? Or red?
Or blue. Green.
All right.
If we take a step back from electronics a little bit and talk about electrics, often we get tempted to just build a harness ourselves. Maybe a couple of things I've got to say to you about there is that we talked about these laws of nature not having been repealed, and they're still valid. Let me tell you, the one written by Owen, that one is still valid too. You can't have a situation where you're putting less out from the alternator than your system is taking, and the battery can hold. The battery's an accumulator, it holds the power. Many times we've seen cars run out of steam. Do I see the Delft people nodding down there? In the days before this team, when the Delft team were very fixated on reducing weight, they thought, oh, we don't need to carry this great big battery, carry a little battery.